Hey, can you teach me how to play this solo? I will not teach you. Linear algebra will teach you.
Linear algebra, how is it possible?
Let me show you. Automatic music transcription is a central topic in the field of musical signal processing, and accordingly, there have been many attempts to achieve automatic music transcription. The difficulty lies in the overlapping of harmonic components generated from different notes. Various methods, including non-negative matrix factorization, have been developed to tackle this difficulty. The goal of our video is to explain the underlying linear algebra concepts using the IEEE paper, an online algorithm of guitar performance transcription using non-negative matrix factorization by Masaki Otsuka and Tetsuro Kitahara. When multiplying matrices, the dimensions of the factor matrices may be significantly lower than those of the product matrix, and it is this property that forms the basis of non-negative matrix factorization, also known as NMF. NMF generates factors with significantly reduced dimensions compared to the original matrix. Given an m-dimensional random vector V with non-negative elements whose n observations form a data matrix V, NMF seeks to decompose V into non-negative basis matrix W of size m cross R and non-negative coefficient matrix H of size R cross n such that V is equal to W into H. Hence, NMF decomposes each data into the linear combination of the basis vectors. Because of the initial condition where R is less than m or n, the obtained basis vectors are incomplete over the original vector space. In other words, this approach tries to represent the higher dimensional stochastic pattern with far fewer bases, so the perfect approximation can be achieved successfully if the intrinsic features are identified in W. The property that all three matrices have non-negative elements makes the resulting matrices easier to inspect. Since the problem is not exactly solvable in general, it is commonly approximated numerically. The factorization is not unique, and various algorithms exist for carrying out this factorization.
NMF is very well suited to learning representation of musical notes based on their magnitude power spectra in the frequency domain. In the paper, the matrices W, H, and V have the following interpretations. W represents the basis matrix consisting of multiple basis vectors, each of which represents the spectrum of different notes. H is the gain matrix for each basis vector at each time, and V is the power spectrum matrix containing the audio spectrogram. This method, known as baseline method, can be applied after the spectrogram V is observed. In other words, after the performance is complete. To use this technique for an online algorithm, we adopt a two-stage strategy. In the first stage, the user plays all chromatic notes successively using the same guitar as the one that he or she uses in the second stage. Once the performance is complete, NMF is applied and then the basis matrix is obtained. We prepare 35 basis vectors, although each string has 23 notes. After the NMF, pairs of basis vectors that have high cosine similarity are searched and then merged. In the second stage, the user plays a phrase which is to be transcribed. While he or she plays, the gain matrix is estimated in real time using the basis matrix which is obtained in the first stage. For every 100 milliseconds, the power spectrum vector Vt is obtained with the Fourier transform, and then the gain vector Ht is calculated. The gain vector Ht is defined as Ht equals W inverse Vt, where W is the basis matrix obtained in the first stage. Because W is not a square matrix in general, its inverse matrix cannot be calculated. We therefore use a pseudo-inverse matrix instead. After the gain vector Ht is calculated, it is compared to experimentally determined threshold. When the value of a certain element of Ht is higher than a threshold, though that of Ht minus 1 is not higher than the same threshold, a MIDI note on message for the corresponding note number is generated, and vice versa for a MIDI note off message.
The above mentioned method involves the thresholding, but the appropriate threshold depends on various factors, including the individuals of the instrument, the strength of picking, and the characteristics of the performer. The dynamic adjustment of the threshold is not easy, and hence we add one more preliminary performance. the correct transcription of which is given, and adjust the threshold using this secondary preliminary performance. Using the sigmoid function instead of simple thresholding, adjusting the threshold becomes equivalent to learning a neural network. The main performance is transcribed using this neural network. We therefore see the transcriptions by the proposed non-negative matrix factorization method successfully reduced false notes and noises from the previous methods. We can further increase the accuracy of the gain matrix by further increasing the number of preliminary performances. We therefore see that large number of linear algebra concepts, especially the non-negative matrix factorization, contributed effectively in formulation of mechanism for online transcription of guitar performances. Thanks to linear algebra, right?
Yeah, right.
Thank you.